integration, the word integration. Integrate karna, collect karna, right? So abhi in the previous class you had done differentiation, right? In the previous class we have done differentiation. Differentiation mein we break a thing into several parts like this. Okay, we break a thing into several parts like this, and we just study one part of this, and on the basis of this one part we come to a conclusion about that thing. For example, as I had taken a ring, right? एक आपको शो किया था ना मैंने slinky में. Slinky is made up of so many rings, right? So in this, in differentiation, we study just one ring and we try to understand its structure. In differentiation, we collect all these parts, we integrate all these parts to understand the whole. For example, in case of this cylinder, if we integrate all the rings which make up this cylinder, then we get to know, yes, it is a cylinder. And the width of each ring, suppose we have n number of rings, and width of each ring is, let's say h dash. Okay, then height of the ring will become, height of the cylinder is, how will you calculate height of the cylinder? We can calculate height of the cylinder as nh dash. Right? So when we collect all these rings together, then cylinder is formed. In the same way, in integration, we collect all the parts together and we integrate them to get the whole, to understand the whole. Okay. So for example, let's consider a function fx. And this fx is equal to x square. Okay. So when we differentiate, on differentiating fx, with respect to x. So when we differentiate fx with respect to x, we get f dash x. And this is equal to dy dx of 2x square, right? And what is the value? It's 2x. Okay. So in the same way, see, this value that we are getting is 2x. This is, let's say, it is some other function of x. Let's say gx. Okay. So when we differentiate fx, then we get gx. Okay. When we differentiate fx, we get gx. Gx is another function, some other function of x. As fx is a function of x, in the same way gx is a function of x, but they have, you can see in fx we have x square, while in gx we have 2x, so they are different. Now, if I write fx as this dx is in the denominator, so we can move this dx to the other side and we get gx and dx. Okay. And here we have d. So we have function of x, d, but we have d here. So what does d represent? What does this d represent? We had differentiation. ठीक है, differentiation ही represent करता है. As in the previous class, we had taken one example of velocity and we had found out velocity by differentiating the position vector. And I told you that we can write this dx as x2 minus x1. This dt can be written as t2 minus t1. So it is nothing but a small portion of fx, we can say, right? Suppose we have x-axis. This is our x-axis. This is origin and this is x-axis. And on the origin, we are taking these 2 points. This point is x1, this point is x2. So this distance is x1 basically, right? And this distance is x2. So this whole is x, right? So these are only the parts of x, we can say. These are only the parts of x-axis. So when we integrate all the parts of x-axis, then we get the complete x-axis. In the same way, if I integrate this dfx, I will get the complete fx as a function. Okay, so we need to integrate all these small parts to get the whole. So we will integrate this dfx to get the whole, to get its whole. So because we have, this is a sign of integration. This curly line is the sign of integration. So we need to put this integration sign here as well. So we will get this whole, this complete fx, and this complete fx is the integration of gx. Okay. So now you just compare these two things which we have written here. One is this, and the second is this. When we differentiate fx, we get gx. But when we integrate gx, we get fx. So integration is just the reverse of differentiation and nothing else. Integration is the reverse of differentiation. So when we are differentiating fx, we are getting gx. But on integrating gx, we are getting fx back. Okay. So it is the reverse of differentiation. Okay. Should I clear the screen? Suppose I have a, as we had taken here, it means that because, see, I have fx is equal to x square. So when we differentiate fx, we get 2x. This is what we had discussed, right? And this is another function. It means when we will integrate this gx, we'll get our fx back. Okay? यही किया ना अभी. तो जब हम gx को इंटीग्रेट करेंगे, मतलब जब हम 2x dx को इंटीग्रेट करेंगे, then we will get our x square back. So on differentiating 2x, sorry, on differentiating this x square, we are getting 2x, but on integrating this 2x, we are getting our x square back. Okay? Any doubt? Need to learn this. Okay? So you can see, as we have number of examples here, displacement, velocity, and acceleration, these are used. In work done by constant force, we can find work done by variable force using integration. We can find potential energy for a conservative force. You can see the integration symbols here. Buoyant force, pressure force, heat transfer, change in entropy, electric field from a continuous charge distribution, magnetic field from a current distribution. So we have a long list of formulas where integration symbols or integration is used, and this is the reason we study integration in physics. Okay. The process of integration is just the reverse of differentiation. This we have already discussed, right? So the symbol, this curly line, is used to denote integration. Should I move to the next slide? This we had discussed. So if we differentiate x cube, we get 3x square. And when we integrate 3x square, we get x cube back. So these are the formulas you can see of integration. See, if for xn dx, we write xn plus 1 upon n plus 1 plus c. Here c is nothing but constant of integration. This c is called constant of integration. Please write this formula first. This c is constant of integration. Written. Suppose I have integration. We have to integrate x square. Okay. Now what should I write? N is equal to 2. We have n is equal to 2. What should I write? X, बताओ. X raised to the power, we have n is equal to 2. 2 plus 1 divided by 2 plus 1 plus c. This c represents constant of integration. So we will get the answer as x cube by 3 plus c. Okay. This is called, this type of integration is called indefinite integration. Okay. Suppose now I have limits. We can also put limits to the integration symbol. You can see. See, if I have 1 to 2. So this limit is called the lower limit and this 2 is the upper limit. 1 is the lower limit and 2 is the upper limit. Now I'm integrating the same x square. Okay. No doubt we will get the same answer. We will get the answer as x cube plus c. But this time we will not write this constant of integration. Instead, we will just write the limits here like this. This type of integration is called definite integration, where limits are given. Where limits are not given, then integration is indefinite. But if limits are given, then it is definite. Okay. Now what we do is, see, first we will write the upper limit in place of x. Because see, here we have dx. Now we are integrating. We are considering this x, right? So these limits belong to x only. Okay. So first we will put the upper limit in x. Upper limit is 2. It's 2. So in place of x, we will write 2. It's 2 cubed by 3. And then we will write the minus sign. And now you put the lower limit in x. So when we put the lower limit in x, we get 1 cubed by 3. Now tell me, what will we get? It's 8 by 3. And here we have minus 1 by 3. So answer is 7 by 3. Okay. So if limits are given, then we will solve like this. But if limits are not given, we will simply integrate it and put a c here. The c represents the constant of integration. Okay. So this is the first formula. We have dx. Then how will we integrate? Nothing is written before dx. So we can simply write this dx as 1 into dx. And this 1 can be written as x raised to the power 0 into dx. Now we have n is equal to 0 here. Okay. So for n is equal to 0, we can write use the formula. It's xn plus 1 upon n plus 1. So x0 plus 1 upon 0 plus 1 plus c. And the answer is x plus c. What if I have 1 by x dx? So can we differentiate this? Using the same formula, can we differentiate this? No. I'll show you how. We cannot write, if we write, we cannot use this formula. We cannot use this formula. Okay? No. Correct? Karke dikhao. What if we use this formula? See, if I use this formula, we'll get this. So n is minus 1. So we'll get minus 1 plus 1 upon minus 1 plus 1. In the denominator, we are getting 0. So we cannot use this. So if we have 1 by x dx, so instead of writing like this, we write, what do we write? What do we write? Log x plus c. Okay. So for 1 upon x, it's log x plus c. Integration of sin x dx is, tell me. See, when we differentiate cos x, then we get minus sin x. When we differentiate cos x, we get minus sin x. So when we'll integrate sin x, we'll get minus cos x. Okay. So sin x dx is cos x, and in cos x dx is sin x plus c. Okay. When we differentiate 10x, then we get sec square x. So when we'll integrate sec square x, we'll get 10x. Okay. When we differentiate cosec x. When we differentiate cosec x, then we get minus cosec x cot x. So on integrating cosec x cot x, we'll get minus cosec x plus c. Okay. On differentiating sec x, we get, when we differentiate sec x, we get, no, it's sec x 10x. Okay, so on integrating sec x 10x, we'll get sec x. Okay. On, we have not written one now. When we differentiate cot x, then we get minus cos x square x. So when we'll integrate cos x square x, then we'll get minus cot x plus c. Okay. And when we differentiate e raised to the power x, then we get the same ex. So on integrating, we'll get this only. Okay. So when we differentiate log x, then we get 1 by x. So on integrating 1 by x, we get log x. Okay. In the same way, we have a formula for ax dx. It is ax. Here we divide by log a plus c. Any doubt? Please write all these formulas. So let's integrate. Question number 1. Integrate x plus x square dx. We'll integrate them separately. Okay. So first integrate x dx and then write this plus sign and now integrate x square dx. Which formula will be using here? We can use here. Tell me. X and dx, right? X and dx is xn plus 1 upon n plus 1 plus c. We will use this formula to solve this. Here we have n is equal to 1. So it is 1 plus 1 upon 1 plus 1. Let the constant of integration for this particular integration is c1. And for this integration, let's take the constant of integration as c2. So it's x square upon 2 plus x cube upon 3. And here we have c1 plus c2. So we can write another constant of integration for this. So we can write here c is equal to c1 plus c2. Okay, this is the answer. Second, evaluate. One to 4 x cube dx. Okay, now here we have limits. So you don't need to write constant of integration this time. Okay, so tell me, what should I write? Yes, it's x 3 plus 1 upon 3 plus 1 and we'll write the limits here 1 to 4 and next step is x4 by 4 limits 1 to 4. Now first we put the upper limit 4 is to the power 4 divided by 4, then negative sign, and now we'll put the lower limit. So we'll get 6. This is 64, you know? 4 cube is 64 and minus 1 by 4. Answer is 63.75 because it's 1 by 4 is 0.25 in decimals. Okay, so answer is 63.75. Third question. Evaluate x minus cos x plus 1 by x. So first we will write them separately. Okay, it's x dx and we have a negative sign cos x dx. Then we have a positive sign, 1 by x dx. What will we get? X on integration becomes x square by 2. Yes. And here, integration of cos x is sin x. And 1 by x is log x. And then we will write the constant of integration. You can either write log with base ex or you can write ln x. Okay. This is log with base ex or ln x. I'm going to clear the screen now. Next question. Now evaluate cos x dx and limits are given. It's minus pi by 2 to plus pi by 2. Now integrate this. What should I write? Cos x is? See, when we differentiate sin x, we get cos x. Right? So on integrating this, we'll get sin x. When we differentiate cos x, then we get minus sin x. So on integrating sin x, we'll get minus. Okay? Plus आएगा, minus आएगा. Should I put a negative sign here? No. See, जब हम sin x को differentiate करते हैं, तब cos x आता है ना. हमने sin में confuse नहीं होना. तो जब हम cos x को integrate करेंगे, तो sin आएगा. Okay? एक तो चीज ये हो गई. When we differentiate cos x, then we get minus sin x, ना? So on integrating sin x, we get minus cos x. Okay? This is the difference. So we'll get sin x. Now, write the limits. It's minus pi by 2 to plus pi by 2. First, we'll put the upper limit, sin pi by 2. Then we will put a negative sign and then sin minus pi by 2. This we had done in trigonometry. Sin minus theta is? No, you're not revising. Sin minus theta is minus sin theta. Cos minus theta is? No, it's plus cos theta. भूल गए ना? प्रैक्टिस तो खुद करनी पड़ेगी ना. Sin pi by 2. Now we can write minus sin by 2 pi by 2 for this. So minus minus plus sin pi by 2. Sin 90 degree. Pi by 2 is 90 degree. So 1 plus 1. Integration by substitution. So substitution, the word substitution means किसी को किसी की जगह पे रखना, substitute करना, replace करना, right? Okay. So let's integrate now by substitution method. Suppose we have sec raised to the power 4x 10x dx. Now we have to integrate this by substitution method. Okay. So how will we integrate it? Tell me. कैसे करें? क्या कुछ connection दिख रहा है? Right. When we integrate sec x 10x, then we get sec x dx. Sorry, sec x, है ना? Sec x plus c. On differentiating sec x, we get sec x 10x. अब कोई कनेक्शन दिख रहा है क्या? क्या कनेक्शन दिख रहा है? What if I put z is equal to sec x? If my z is sec x, then on differentiating z with respect to x, we will get dz by dx as, sorry, we are putting this z is equal to sec x. Z is sec x. Now on differentiating z with respect to x, what will we get? We'll get sec x tan x, right? Okay. So we can write dz as sec x tan x and dx. Okay. अभी क्या किया हमने? We have kept this z as sec x, and then we have differentiated this z with respect to x. We've got this sec x tan x, and then dz is sec x tan x dx. Okay. Now consider this integration. So we can write this as sec cube x and sec x tan x dx together. Can we write like this? This sec raised to the power 4x can be written as sec cube x into sec x. Okay. This sec x is nothing but z. So in place of sec x, now we will write z. Okay. So it's sec cube x. So sec cube x means it's z cube. And this sec x tan x dx is dz. Can you integrate it now? We are integrating. Yes, it's z4 upon 4 plus c. So we have used this added formula, na? X and dx. It's xn plus 1 upon n plus 1 plus c. Right? So this is the answer for this particular integration. Okay. Now, this implies, or therefore, we can write sec 4x, 10x, dx. As in place of z raised to the power 4, we will write this again. Z is sec x, okay? So it's nothing but sec 4x upon sec raised to the power 4x upon 4 plus c. So this is how we integrate by substitution method. Was that difficult? Easy. You only need practice. Okay. Write the question. Evaluate integration of, we have 1 upon ax plus b dx. Okay. See, we'll solve these questions in two different ways. So first, draw a line in the middle. Here we are using integration by substitution. Okay. Method 1. Put ax plus b is equal to z. On differentiating z with respect to x, we get dz by dx is equal to d by dx of ax plus b. So when you differentiate ax with respect to dx, oh sorry, what do we get? A, and on differentiating this b, we'll get 0, nothing. Okay. So this dz is a dx. Okay. This dz is a dx. Now we can write 1 upon ax plus b dx in terms of z. So this 1 upon this ax plus b is z. So we'll write z. Okay. And this dx is dz upon a. And we'll integrate this. Okay. So because a is a constant, so we can just write this a outside the integration sign, and in the bracket we have this only. So on integrating 1 upon z, we get ln z plus constant. Now simply write the value of z here. It's nothing but ax plus b, and this is a final answer. Okay, because z is ax plus b, you put the value of z here and you'll get your final answer. This is integration by substitution. This we have already discussed. Okay, second method is method 2. In this method, see, we can consider this ax plus b as, let's say, capital X. So what if we integrate something like this? What if we integrate this? We get ln x plus c, right? So in place of this x, we have ax plus b this time. So we can write ln ax plus b. Okay. So now whatever you have, see, but we do not have x. We have ax plus b. Now differentiate this ax plus b with respect to x and write the thing, the answer that you'll get in the denominator. So d by dx of ax plus b, and then write constant of integration because there are no limits given. Okay, now what will we get? Ln ax plus b. In the denominator, when you differentiate ax with respect to dx, you will get a. On differentiating b with respect to dx, you will get nothing, 0. So are we getting the same answer? We are getting the same answer, right? Any doubt? Question now. Evaluate 0 to 10 is the limit. Okay. Sec square 3x plus 6 dx. Okay. So when we integrate sec square x, see, on differentiating 10x, we get sec square x, right? So when we'll integrate this sec square x dx is 10x plus c, right? So what should I write? Tell me. Sec square hai, so answer is 10. Okay. In the bracket we have 3x plus 6. Itna to samajh aa gaya. But see, in the bracket we do not have x. We have something in the bracket which is not x. Okay. So we will differentiate that part in the, and we'll write the thing in the denominator part. And because limits are given and therefore no need to write constant of integration, simply write this 0 to 10. Okay. So we'll get 10 3x plus 6. And on differentiating 3x with respect to x, we get 3. And plus 6, we'll get nothing, 0. Apne ko aa gaya. Now, 1 upon 3, 10. X is 10, okay? So 36 minus 10. Here we will put 0. So 0 plus 6 is 6. Answer is 10 36 degree minus 10 6 degree upon 3. 10 36 degree minus 10 60 degree upon 3. This is the answer. Okay. Next, write the heading integration by parts. Integration by parts. Underline this. Suppose we have something of the form u v dx. So here u is a function of x, some variable x, and v is also a function of x, some other function of x. Okay. So these two are function of x, and they are in the product form here, and we have to integrate them. So how will we integrate? See, first we will write the first term u, integrate the second term v dx. Okay, write the first term as it is and integrate the second term. Then put a negative sign. Sign of integration. Differentiate the first term. Differentiate the first term. Whatever you'll get here, v dx on integration, that thing here, the same thing v dx, integrate the second term and dx. And now we will integrate this complete term. It looks complicated, but it is not that complicated. It's easy. Okay. So whatever you'll get here when you integrate v dx, that thing you have to write here as it is. And this u is the first term. You will be differentiating this term. And whatever you will get on simplification, that has to be integrated. Okay. Let's try one question based on this, and then it will be better clear to you. Suppose we have something like, let's take an example. Now we're going to evaluate x cos x dx. Okay. So what is u here? U is, tell me, u is x and v is cos x. It depends on you only. You decide, okay, that which you want to take as u or v. It's your decision. Okay. So because a cross b is b cross a, no? They are commutative. It doesn't matter. So now what should I do? Tell me, what should be my next step? We'll write this x as it is and integrate the second term cos x. Okay. Now negative sign, sign of integration, and then bracket. First term, we are going to differentiate the first term. It's x, so dx by x, dx. Okay. Now integration sign, and we will write this cos x dx, square bracket close, and dx. Okay. Now tell me, when we integrate cos x, we get sin x. Simply write sin x here. Negative sign, follow this integration sign. Dx by dx is nothing but 1. No need to write anything. And cos x dx is sin x and this dx. Okay. Next step would be x sin x. Integration of sin x is minus minus becomes plus cos x. And because there is no limit, so we will write plus c at the end. This c is the constant of integration. Integration, evaluate this. X raised to the power n log x dx. So see, this time take this as u and this as v. Okay. So first we'll write u, and then we integrate v, then minus sign, then integration, square bracket, and we differentiate log x. Write this part as it is, x and dx, bracket close, and dx, right? This is how we write it, na? So log x, this x and dx is x raised to the power n plus 1 upon n plus 1. Okay, minus integration. When we differentiate log x, we get 1 by x When we integrate this x and dx, we get xn plus 1 upon n plus 1 and dx. ठीक है, अब क्या करेंगे नेक्स्ट स्टेप में? x n plus 1 log x upon n plus 1, and here we can write, simplify this 1 upon n plus 1 outside. In the integration, we'll get x n plus 1 minus 1, because we have x n plus 1 in the numerator and in the denominator we have x, right? So we can write x, this is x raised to the power 1 now. So n plus 1 minus 1. So it is x raised to the power n only. So x raised to the power n dx. Easy? X n plus 1 log x on n plus 1 minus 1 by n plus 1, and this is nothing but x n plus 1 upon n plus 1 plus constant of integration. We can further write this as, we can take this common, no? This n plus 1 belongs to both. This xn plus 1, xn plus 1 belongs to both. So we can write xn plus 1 upon n plus 1. In the bracket, we'll have log x minus 1 by n plus 1 plus constant of integration.